Hello everybody, and in this video we'll be going more into depth on limits and just kind of looking at examples and identifying them. Okay, our first problem, and this is, by the way, is Khan Academy. Is a great website. Feel free to check it out on your own. And this topic is approximating limits from graphs. The function h is defined for all real numbers, and this is the function h here. What is a reasonable estimate for the limit of h of x as x approaches, and that says -2. So -2 is right here. It's kind of hard to draw, my bad. Draw a straight line. So -2 is right here. So we see these points, these points, these points. Alright, and as x approaches -2, and this is just in general, not from one side. So as x approaches -2, we see here that it gets closer and closer and closer to -4. That's -4 right there. And then from this side, and in order for this to work, it has to be equal for both sides, because this is a basic limit. And as x is approaching -2 from the right, it's also approaching -4. But we see -4 is not an answer here. So what's one of the closest answers to -4? We see that it's around like a little higher. So -3.8 would be a good answer. And that's right. For the next example, we have the function f is defined for all real numbers except for x equals -4. So this is kind of like the last video where there's just a gap. So -4 is undefined. So and this is a graph right here. What is a reasonable estimate for the limit of f of x as x approaches -4? And again, it has to be from both sides. So we see here it's approaching 4 from the right, and it looks as if it would be hitting 6. That's what it looks like. And then from this side, same thing, 6. And so let's say we take, if x is -3.99999, it looks to us like a 5 point, as y would be like 5.99. So we see it's getting closer and closer to 6. So we'd say 6 for this one. And that's the correct answer. And for this one, the function h is defined for all real numbers. Okay, so for all real numbers, that's just like positive, negative numbers. Okay, and you see a gap right here at x equals -5. So you say, okay, this must be defined. But the point here shows that no, it is defined. So x of -5 is defined, but just at a different point. So it's just like a basic parabola, and then there's this, and then there's just it's just defined somewhere else. So as x is approaching -5, we see, so let's draw again here, from both sides again, it looks as it's not approaching 2, a little less than 2. So I give it like a 1.8, 1.7. And then from the left, as x is approaching 2, same thing. It looks as if it's approaching 2 again, or like 1.8, 1.7. So as x is approaching -5, for the answer we'll choose 1.7, which is D. And that's the right one. And for this one, the function g is defined for all real numbers. So what is a reasonable estimate for the limit of g of x as x approaches 3? And remember, so it has to, since this is not a one-sided limit, the limit has to be equal from both sides. So from the left, we see x is approaching 3, going here, and it looks as if it's going to hit 4. So the limit, so as x approaches 3 from the left, looks to be 4. And from the right, as x is approaching 3 from the right, it looks to be -3. So you think, okay, but these are different answers. So if we would write this, the limit of x minus 3 of g of x equals, and that's, so if you approach 3 from the left, we'll get into this into another video. From the left, it looks to be approaching 4. But from the right, again, we'll get into this in another video, it looks to be approaching -3. But those are both answers. Since they are not equal from both sides, we can only conclude one thing, that the limit does not exist. And that's enough practice for this time. Thanks for watching. See you guys next time.